We're ready for example 2, part C here. All right, we're going to integrate. You'll notice that some of the rewrite has been done from the question to the board here. We changed that radical into a fractional exponent, in this case 1/2. And then because of the fact it's on the bottom, we pull it up, and that would give it a negative 1/2 power. So again, if it's in the denominator, it's going to have a negative power. If it's a radical, it'll have a fractional power. And so those two things combined give us this. There is not a product rule for integrals. There is not. So that would be a tip-off to you. And again, when you're doing assignment 27, you'll be doing substitution on every one of these. So this again would be a definite integral, Roman numeral number 2. And since we have that quantity being raised to a power, that would be the logical thing to set equal to u. So u will equal x plus 5. And we're going to build this new integral over here. Goodbye, x. You're too complicated for me. I'm going to go run off with u. So then that would be u to the negative 1/2 power within the new integral. And that part of this has been replaced. What's another word for replaced? Substituted. All right. Then, of course, we always want to get our dx. So that provides the motivation for differentiating both sides with respect to x. And then if we clear the fraction, so to speak, we end up with du equals dx. And so in this case, the du will straight up take the place of the dx. And that'll give us du here. All right. Now, unlike the previous example, watch them in sequence. The 2x didn't fall in our lap. The 2x didn't fall in our lap. So, what I would always tell a person is after you make your original substitution and you build your dx, if there's additional expressions out here, you build them from your original substitution. So the point is we need to build a 2x from this. So the process of doing that, in my opinion, let me just transfer this over here so that we can show the work behind that. If u is equal to x plus 5, here's my thought. I would build an x first from that. Solve this for x, in other words. So, if you solve this for x, which would be to subtract 5 from both sides, you would then learn, again, from that original substitution, that the expression u minus 5 is equal to x. That's just a rearrangement of that original substitution. Everything gets built from that original substitution. Oh, I don't want just straight x. The integral wanted 2x. So you would hopefully look at this and you say, oh, well, let's multiply both sides by 2. See, we're building it. If that was a 9x, we'd multiply both sides by 9, you know? So the point would be here, it turns out that the expression 2x that's in the original integral would be equivalent to the expression 2u minus 10. And there you go. There would be something we could replace that 2x back there with. 2u minus 10. So 2u minus 10, let me give myself a little more room here. 2u minus 10 would equal that 2x back there in the original. Replace everything. Sometimes that expression will fall in your lap. Other times you have to, what I like to call, construct it or build it. All right, so this would be, so far, this would be identical to example number 1 in terms of the idea behind changing everything over, replacing, substituting everything in the original with a new expression. All right, and then here's the part that's easy to forget here, because this is what's new, is changing our limits of integration. So I'll remind you, everything's built off of that original substitution. If 0 is a value of x, then 0 plus 5 would be 5. So when x is 0, u would equal 5. There's a new limit of integration in town, a new lower limit of integration. There's also a new upper limit of integration. Same thing, we go put 1 in for x. 1 plus 5 is 6. So that upper limit changes to 6. And there's our new integral. And guess what? We're never going back to our x. Why? Because we're definite about that. All right, that's what's different between this one and the indefinite ones. I want to remind you on the indefinite integrals, We replaced everything, we integrated, and we went back to our x. We substituted back. But on a definite integral, we're like, goodbye x, I'm running off with you, and I'm starting a whole brand new life. We should be able to finish the question from here, because remember, definite integrals give us numbers, numerical answers. And we're going to get that number from here. All right, so we have from 5 to 6 different limits of integration. Now you might say, well, wait a minute, you still have a product here. Indeed, that's true. However, this product that we created over here is different than the one over there, because here we can distribute that into the parentheses. We couldn't do that back here. That's the point. It's still a product, but it's a different sort of product. And so if we distribute that u to the negative a half into the parentheses here, 2u to the first times u to the negative a half would be u to the positive 1/2 minus 10u to the negative 1/2, properties of exponents, du. Guess what? We got terms and powers now. All right? So there we go. We can integrate each term using that power rule that was introduced several sections back. And so now we're ready to integrate this thing. That'd be 2u n plus 1, right? 1/2 plus 1 is 3/2. And then I can't say it enough times. Instead of putting that over 3/2, u to the n plus 1 over n plus 1, the power rule for integrals, division by 3/2 is the same thing as multiplication by 2/3. So that would be the antiderivative of that term. And then we have minus 10u. Okay, negative a half plus 1 is positive a half. And again, instead of dividing by a half, we will, in our head, we will invert multiply. Division by 1/2 is multiplication by 2 over 1. All right? And now that the integration has been performed, we've found the antiderivatives of these terms, we would then say, this whole thing shall be evaluated from 5 to 6. And in all honesty, the rest of this is mechanical arithmetic. And I believe it's fair for me now at this point to say, you ought to know what to do by this point. Okay, I'll do one more. Now, you should clean this up, right? That'll be 4/3, that'll be 20. You know, do some things like that, simplify it a little bit before you go plug the numbers in. And then I'll just point out from here, and I would show more steps. I'm afraid that board space is at a premium, but to be honest, the remaining steps are just arithmetic. Stick the 6 in for u, crunch, 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 get a number. Stick the 5 in for u, crunch, 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 get a number, and then subtract the 2. Remember, the f of b minus f of a idea that we had before. I guess I'll take you back to that. Right? This is what we're talking about. This is the old notes, right? Put that upper limit in, crunch it, put the lower limit in, crunch it, subtract the 2. That's arithmetic. So again, that arithmetic will lead us to approximately 0.42036, and it goes on. Good enough, all right? So keep in mind that definite integrals are going to provide numbers for answers. And so if we change those limits of integration, we never have to go back to our x, all right? And that's cause for celebration, isn't it? All right, so there would be that one. Let's just keep practicing.